All right, so this is the graphing exponential function worksheet. First thing you need to copy down is the definition for exponential, which just means something growing or decaying really, really fast. We already talked about something that was growing really fast, and that was your money in the compound interest formula. That was one example of an exponential function. So for this first one, y equals 2 to the x power. We're going to use our graphing calculator to help us out to graph this. So go to y equals and type in 2 raised to the x power. So that's 2. The raised 2 button is this button above the division sign. And then x is this button to the right of the green alpha key. Graph it to just get an idea of what the graph looks like. And then notice how it just takes off and it is growing at a really rapid rate in this problem. So we're not going to sketch that, but we're going to get specific points by going to the T-chart in the graphing calculator. So go to second graph, and let's look at our T-chart. So we want to look at the values that correspond to the T-chart that they've given to us here on number 1. So go ahead and find those and fill those in. So you should get the values that I have listed there when x is -3, y is 0.125, and of course you can get the rest just by looking and scrolling up and down in your T-chart in your graphing calculator. One thing to notice with your graphing calculator, as the x's are getting smaller, notice what y is approaching but never actually hits. Y is getting really, really small, but it never actually hits 0. In fact, eventually you get an error message because the number is too small for the calculator to calculate. So the y's never hit 0 for this function. But let's go ahead and graph these points. Just do the best you can. I know a couple of these are really small decimals. And then sketch with a smooth curve. Should never actually touch the x-axis, but it's going to get really close. And now let's answer the questions. The first one is the x-intercept. We just talked about this. It does not touch the x-axis. It's getting really, really close, but it never actually intersects the x-axis. It does, however, hit the y-axis at the point 0, 1. The domain for this graph, you should notice, is all real numbers because it's going left and it's going right infinitely. The range, though, there's a lowest point for y, for the y values. It doesn't go past the x-axis, so y never actually hits 0, but it does go above 0. So the range is y is greater than 0. And then finally, the asymptote. We've talked about this a little bit, but I've listed the definition down here. The definition of an asymptote is just the boundary line that the graph never crosses. So the asymptote in this problem, you could either say is the x-axis or the line y equals 0. We're going to skip 2. So we're not going to do 2, but we're going to look at 3. There's no, just for time's sake, we're skipping 2. There's no real reason that's a problem. Eventually you'll be able to do with no problem at all. But number 3, notice this one says we're using transformations to graph this function. So this is just a shift of the parent function. So this is the parent function that we're going to be shifting all over the place in this worksheet. So first, just in really light pen or pencil, and I'm actually going to use a yellow highlighter here, I'm going to regraph that parent function. So these are just the points that we just graphed. And what we want to decide is, how does this function shift the parent function? Remember from a couple units ago, if the number is on the inside, and this plus 3 is on the inside of the exponent. So if the number is on the inside, it shifts the parent function horizontally. And if it's a plus 3, I about wrote it the wrong direction, it's going to shift the parent function left 3 units. So what we're going to do is we're going to take those parent function points and shift them left 3 units. And that includes the tail. So that is the function y equals 2 raised to the x plus 3 power. And you could always put this in the graphing calculator to verify that what you have is correct. So if we type that in the graphing calculator and graphed it, you'll see it looks like it crosses the y-axis at the same point. So now let's answer these questions. Notice there's still no x-intercept. This one still does not cross the x-axis. It does cross the y-axis. Looks like at the point 0.8. The domain for this one is all real numbers, because again, it's going left and it's going right infinitely. The range is the same as the last problem because this one has not been shifted vertically at all. And same thing, the asymptote is the same. It's approaching the x-axis. It's getting really close, but it never actually touches. It's not been shifted vertically at all. These things are not going to change. For this last one, number 4, that plus 1 is on the outside. So it's on the outside of the exponent. So it's going to shift the parent function points up 1 unit. So we're not going to shift left to right at all. This time we're going to shift all those parent function points up 1 unit. So again, I've got the parent function points listed in yellow. You don't have to do that, but if that's helpful, you can graph the parent function and then shift those points up 1 unit. And then notice it also shifts the tail up 1 unit. So now this graph is not approaching the x-axis, it's been shifted up 1 unit. So if we type this in the calculator to verify it, I'm just going to delete that one. So we type it in and we graph it, and notice the tail now has been shifted up 1 in our graphing calculator. And we can also look at the t-chart. Notice what the y values are approaching this time. This time they're getting really close to 1, but they never actually get to 1. So that's our graph for this one using transformations. And now we can answer the questions. There's still no x-intercept. Notice if this graph was shifted down, which could happen, we would have an x-intercept, but not in this case. The y-intercept is the 0.02. The domain is still all real numbers, so it's going left and right infinitely. The only thing that really changes here is the range. Now y is greater than 1. It never gets to 1. But our asymptote in this problem is right here. And it's the line y equals 1. Go ahead and try number 5. See if you can figure out where the parent function would shift. And so go ahead and pause the video, try it on your own, and then you can play to see if you got it correct. All right, so that should be number 5. It's been shifted down 1 and right 2, which means this one has an x-intercept. The x-intercept looks like it's at the point 20. The y-intercept, you could estimate there what it is. It looks like it crosses at a decimal. Domain is still all real numbers. But the range, since this has been shifted down 1 unit, the range is y is greater than or equal to -1, and the asymptote is the line y equals -1. All right, so this last one, number 6, two things that are happening here. Remember, the negative out front essentially just means it's flipped upside down, or another way to put that is it's reflected across the x-axis. So two things are happening in this problem. It's reflected across the x-axis, and it's also obviously shifted up 3 units. So let's see what that would look like if we shift these parent function points. So this first point here in yellow from the parent function, it's 1 above the x-axis, so its reflection is just going to be 1 below the x-axis. The second point here is 2 points above the x-axis, so its reflection is 2 points below, and then so on and so forth. So the third point is 3 points below. Actually, I think I have that one off a little bit. That one should be at 2,4, which means the reflection would be at -2,4. And this last point will be way down here. And the same thing happens to the tail. So the original graph, again, looks like that. So this new graph has just been reflected across the x-axis. Then once you reflect it across the x-axis, then you need to shift it, all those points, up 3 units. So this point shifted up 3 units goes there. And the tail has also been shifted up 3 units there. So the green graph is the answer. And then you can answer x-intercept, y-intercept. Our domain is still all real numbers. The range this time, notice the graph this time is going down. So the range is going to be y is less than a number. It's going to be less than +3 because our asymptote is this dotted line in black that I'm drawing right now. The asymptote is y equals 3. And the range is y is less than 3.